Okay, negative feedback as a control mechanism in the body. These control mechanisms are designed to try and make sure that you have optimum conditions in the body. It could be, for example, control of blood glucose. It could be control of body temperature. You need these things to be fairly stable. And negative feedback is one way that these things are maintained. My example here is primarily for the WJEC EDUCAS GCSE Biology, which is explaining the role of a hormone called thyroxine in the body as an example of negative feedback control. But this will apply to any example of negative feedback that you wish to explain. First of all, I want to give you an explanation of something we can all understand, which is control of room temperature in your household or any other building. So, room temperature is usually regulated by something called a thermostat, and you have a heat source such as a radiator. So what happens if it gets too cold? If it's too cold, the thermostat should trigger a response as a result of the cold stimulus, which is simply to switch on the radiator. And as the radiator comes on, the temperature will increase, and as the temperature increases, that will be detected by the thermostat, and again that will be a stimulus for the thermostat to switch off the radiator. Once the radiator is switched off, the temperature will drop, and once the temperature drops again, it should then re-switch back on the thermostat to raise the temperature once again by bringing the radiators on. And this continues. It's a constant cycle. So the thermostat is going to detect the cold temperature, switch on the radiator, which increases the heat, and the increase of the heat causes the thermostat to switch off the radiator, which then decreases the heat. All of this is a constant cycle which is going to maintain the optimum temperature, the optimum conditions in the building. So why is this negative feedback? Well, it's negative feedback. Let's go straight from the beginning again. It's negative feedback because you have a stimulus which causes a response. That is not the negative feedback bit. This is the negative feedback bit, is that as a result of the response is fed back to whatever initiated the response in the first place, and it cancels it. Let's include those words negative feedback into the explanation now. It's negative feedback. One, because you originally get a stimulus which brings out a response, but here we get a negative feedback bit now. Once that response is fed back, in this case the increased temperature, it cancels out the stimulus, and this cancelling out part is the negative action, the negative part. So we've had something fed back, we've had a negative response, in other words the response is now stopped. That's negative feedback. Now let's apply this to an example in the body. In this example, I'm going to be looking at the control of thyroxine, which is a hormone which is involved in the control of metabolism, the rate of chemical reactions within your body. So if you have a high level of thyroxine, your metabolism increases. A low level of thyroxine, your metabolism decreases. So let's look at what's involved. Now there's two other hormones involved here and three endocrine glands. What it involves is the thyroid gland, which is now circled on your diagram here, and it's the thyroid gland that secretes thyroxine. Remember, this is the hormone that controls metabolism, and this is the what we need to be able to control using negative feedback. The hypothalamus is also involved. Now the hypothalamus is in the brain, which is now circled in the diagram, and in the inset, the top left inset with the the cut in half section of the brain, it's the bit shaded yellow. That hypothalamus secretes TRH, thyrotropin releasing hormone. You just need to know the initials for our exam board, TRH. The other endocrine gland involved is the pituitary, which you should know by now is called the master gland. Pituitary is now circled on a diagram, and on the inset of the cut in half brain, it's the bit shaded red. The pituitary in this case secretes TSH, which is thyroid stimulating hormone. Now that makes sense with the name because it stimulates the thyroid, which is the gland that now secretes thyroxine. So as a quick overview, the diagram that's now on screen represents a negative feedback control. So before I explain it to you, just pause the video and take a little bit of time to try to work it out for yourself. Right, let's go into it using this diagram now. We've got the hypothalamus labelled at the top, and the pituitary, you can ignore the anterior bit, and then at the bottom the thyroid gland. And note the label at the bottom, target cells throughout the body. So thyroxine has an effect on many cells throughout the body, and they're called the target cells. So let's start from the beginning. If we've got a situation where there's too little thyroxine circulating in the blood, that will stimulate the hypothalamus to secrete TRH, thyrotropin releasing hormone. That in turn stimulates the pituitary gland to secrete TSH, thyroid stimulating hormone, which in turn stimulates the thyroid gland to now secrete thyroxine. And thyroxine will be transported around the body in the blood. So the levels of thyroxine are going to increase. Now we can get to the negative feedback bit, because we don't want to have too high levels of thyroxine. So we need to stop thyroxine being secreted. So we have too much thyroxine. That now has a negative action, a negative feedback on the hypothalamus. And as a result of this, the hypothalamus will stop secreting TRH. At the same time, thyroxine will have a negative feedback action on the pituitary gland. So it will stop secreting TSH. And because we no longer have TRH, which causes secretion of TSH, we now stop the secretion of thyroxine. So it's being negatively fed back. So go through the example why this is a negative feedback response. We had a stimulus, which was low levels of thyroxine, and as a result of which the hypothalamus and the pituitary secreted TRH and TSH. That's the response. Now, the effect of that response is to increase thyroxine levels, and once we had high levels of thyroxine, that fed back to the hypothalamus and the pituitary to cancel out their response. That's the negative action, negative feedback.